Welcome to today's workshop, all about replacing the switches and outlets in your home. My name is Robin Riebel, and I am so excited to bring you a great topic that so many people find intimidating. My job is to try to make this a little less scary. Now, first and foremost, we are going to talk about safety. This is the most important part of any project, but especially your electrical projects. Then we're going to take a look at some of the tools you're going to need for these basic projects. Next, we're going to move into talking about switches, kind of the different kinds, and how to install them. And then finally, we're going to wrap up talking about outlets. We're going to look at a couple of different types, and again, exactly what you need to do to install them. So let's go ahead and get started. Now, before doing anything with your electrical, you need to be safe. And that means turning off the electrical at the breaker. Now, if you've seen our electrical basics workshop, it goes into the importance of labeling your breakers properly. So, when starting a project, make sure that you're turning off the appropriate breaker and then test that circuit with a non contact voltage tester. You're going to want to make sure that everyone is aware that you're working on the electrical so that they don't accidentally turn that breaker back on. You may even want to add a sign to the breaker box itself to ensure that that breaker stays off until you're completely done. Now, I mentioned a non contact voltage tester. That's just one of the tools you may want to have on hand. So let's take a look at some of the other tools that you're going to need for this project. The good news is most of the tools that you need are probably already in your toolbox. Now, there's a couple of specialty tools for electrical, but fortunately, they're not overly complicated or expensive. The first thing you're going to want to make sure you have are screwdrivers. Okay. I like to have both a flathead and a Phillips head screwdriver. Now, you could use your electric drill driver or electric screwdriver, but most of the screws that you're going to come in contact with are not really that big. And sometimes you're working in a tighter space, and that drill driver might be a little bit too much power. I personally like to have a manual screwdriver on hand. Like I said, both Phillips head and flathead. The next thing you may want to have are some pliers, okay? You may have a set of needle nose pliers with a long, thin tip like this, or perhaps even a set of what they call linesman or electrician's pliers. These you'll notice got a blunt tip on them. They have a nice cutting edge, as do the needle nose. They also usually have a good cutting edge on them. The needle nose is great because it lets you get into those really tight spaces like working inside of an electrical box. Now, this is one specialty tool that you should never be without when working with electrical, and that is a good pair of wire strippers. This is going to allow you to strip that outer coating of plastic off the wire to expose that bare wire when you're making your contacts, right? This also has a great edge for grabbing and pulling, and usually will have a nice cutting edge in it as well. So a pair of wire strippers is definitely a must whenever you're doing some electrical work. The next tool that you're really going to want to make sure you have are wire nuts. Wire nuts are so important to your job. Wire nuts are what's going to safely keep your wires together. The most important thing with wire nuts is making sure you have the correct size, right? They come in a variety of sizes. They can hold a variety of different size wires. So you always want to check the package to see what size wire will fit inside what size wire nut. And it's usually labeled right there. That's why I like the combination pack. It gives me a variety of sizes and I can do the most with it. Now, the next specialty tool that you're going to need is that non contact voltage tester that I talked about. This is a really inexpensive tool, but it is so important. This is going to tell you whether there is still electricity running through the circuit or not. It's real easy to use. Just push the button and turn it on. And it's all done with basically lights. So green is good. Green means go. If it is red, that means there's still electricity running through your circuit and it's not safe. You've either turned off the wrong breaker or maybe that particular switch or outlet is on a different breaker than you thought it was. So, this is just a layer of protection to make sure that that electricity is turned off. Now, the final thing that you may or may not need is electrical tape. Now, some people like to use it on the outside of their outlets just as an extra layer of protection. But I will tell you, if you choose to tape inside any electrical boxes or outlets, you must use electrical tape. This is one situation where it really matters. You can't use duct tape or masking tape, anything else. Electrical tape is the only tape that is designed to stand up to the electricity and the heat that's generated where it won't break down and it won't melt. So, electrical tape is important. Now, that's pretty much all the tools that we need. Let's take a look at the different types of switches that you might be working with. So, there are a variety of switches, and they can be grouped together by several categories, right? The first type is by look, and that's usually as long as the switch is functioning, that's really the main reason why people change out their switches. Now, you can have your traditional toggle switch, or just flip up, flip down, or you can have what's known as a rocker or a decora switch, right? And a little cleaner, sleeker look. And a lot of times you can get these in a variety of colors as well, right? So that can help add to the look of your switches and outlets. The next way that we group them is basically control type, meaning how many lights does it control and from how many locations? So the most common is what we call a single pole switch. And then, of course, we always have our three-way switches. So how many lights and circuits? How many locations? The other thing we can always look at is how many switches. So you can get multiple switches kind of in the same footprint or same space. And this is usually used when more controls are needed, but you don't want to go ahead and change the size of the box. Now, in this workshop, we're really going to focus on that single pole switch. And all that means is one switch controlling one circuit from one location, right? So think of it in terms of you walk into a room, you flip on the switch, and the overhead light goes on. And that's all that that controls. One light, one location. Or maybe you walk into your kitchen and you flip the switch and it turns on a bunch of recessed light or maybe a set of pendant lights. That's still one circuit from one location. All right. So they're all controlled by the same switch, one circuit, one location. So that's what a single pole switch is. Now, I want to go through a couple of electrical terms that might be important to you, or just at least that help you understand how a circuit works. So, the electricity that runs through your home comes into the electrical panel or breaker box, and then it gets split up into a variety of different circuits as it's distributed throughout your home. Now, the wires that run from the panel to either the first switch or first outlet in any circuit is called a home run because it's going directly from the panel to the first point in your circuit. Now, from that point, it will then go out to power other things in the circuit. So maybe it's going into the first outlet and it will then control the rest of the outlets in the room. Okay. Now, if you look inside the box, you'll see that there's always should be at least one wire coming in and one set of wires going out. Now, it's not uncommon for there to be multiple wires inside of a box. A lot of times, a couple of different sets of wires will pass through the same box. Now, before we go any further with the circuits, we probably should look a little bit closer at the wires themselves. Most of the wiring in your home is what's called non-metallic cable, which means there's multiple wires encased together in a single outer sheathing. Now, when you're looking at it, you'll see that there's numbers on the outside of the package, usually something like a 14.3 or a 12.3. And these numbers mean something. The first number refers to the gauge of the wire or how thick it is. And the second number refers to how many wires are inside the cable. So this is an example of 14-2 wire. And all that means is that each wire is 14 gauge and that there's two wires. I know, wait, you see 3 wires actually. But how many are colored? Only 2 of the wires are colored wire, and the colored wires are gonna carry the electricity. The bare wire is your ground wire, which is only meant to carry electricity if something goes wrong in the circuit. So much of the wiring throughout your home is probably going to be 14-2 or 14-3, meaning 14 gauge wire and either 2 or 3 colored wires within the cable. Now, there may be some areas that have a 12 or even a 10 gauge wire. The thing you need to remember about gauge is that it's an inverse relationship. The smaller the number, the thicker the wire. Now, the colors of the wire inside the cable also have meaning. So you're going to see a black wire. Your black wire is going to be your hot wire, and your white wire is going to be your neutral wire. If you do have a 14-3, you may also see a red wire. So you'll have a black, a red, and a white. And that red wire will also be a hot wire. So you'll have 2 hots and 1 neutral. That's used a lot in, let's say, a ceiling fan when you want to control both the fan and the light kit. You need 2 separate hot wires. It also can be used if you're going to look at if you're going to have a three-way switch. So now that we've kind of got a little bit of the basics of wiring down, let's take a look at switches and how they're wired. Here's an example of a single pole switch, meaning it controls one circuit from one location. On the switch itself, you're going to notice there's 2 brass colored or gold colored screws, as well as a green screw. Now, these colors mean something as well. The brass screws are there for the hot wires. Okay. So those are the hot connections. And the green screw is for the bare or green ground wire. Now, on this switch, you'll see I only have brass colored screws, and those are for hot connections. And that's because switches are only connected to the hot side of a circuit. They're just there to stop the flow of electricity. Now that we know the major terms and the colors, let's take a look at how to actually replace a switch. We're going to go ahead and replace this typical toggle style switch with a new, updated, kind of sleeker looking Decora or rocker switch. So, the steps in order to do this, the first thing, remember safety first, go ahead and turn off that breaker. You're going to want to remove the plate cover off of the existing switch and check that that power is off with your voltage tester. Go ahead and remove the screws from the switch and pull that switch out of the box. It'll still be attached by the wires, so you want to give it a little bit of tug to kind of loosen up or straighten out some of those wires. Now, if you're unsure of where the connection should go, you should take a picture of how your switch is wired now. You can go ahead and loosen up those gold or brass colored screws and remove those wires from the switch. Then you can go ahead and loosen that green screw and remove that bare ground wire. Now, it really doesn't matter what order you do this in, but you can go ahead and loosen up the screws and take off all of those wires. At this point, you can remove your old switch. Now, when you're looking at that new Decora type switch, you can see that there's really no clear on and off. But if you look closely, you'll see that the top is actually labeled. So it's stamped right there into the metal at the top of the switch. So make sure that that switch is facing up so that you have that traditional up for on, down for off configuration. Go ahead and loosen up the screws on your new switch. It doesn't matter where you start reconnecting your wires, go for whatever is easier. You're going to want to make a loop on your bare wire. Now, you probably already have loops on there from the last switch that you just took out, but you do want to make sure that that loop is curled in a clockwise direction because then that's going to help tighten the loop as we tighten up the screws. So once your wires are connected, again, making sure that all of those loops are in a clockwise direction, all right, you can go ahead and push that switch back into the box. Now, if something happens and a loop breaks while you're trying to reconnect it, you can usually strip back that wire and create a new loop. There's usually about 6 inches of extra wire inside those boxes. So you really only need to strip about a half an inch, and there should be plenty of wire inside the box to make you do that. Once you've pushed your switch back into the box, tucked all those wires in, you're then going to want to screw the switch into the box and then finally put back on your switch plate cover. At this point, you would go turn on your circuit and test the light to make sure that it's working. Test the switch to make sure it's working. And that's really all there is to replacing a switch. Take off the old wires, put on the new. The important thing is that you know exactly where to put them. Remember, those gold or brass colored screws are only for your hot wires, which will be either usually black or red. Now, that's the basics. It really doesn't matter what type of switch you're installing. The process is going to be exactly the same. Take, for example, a dimmer switch, and there's tons of different types of dimmer switches. You have sliders and you have dials and rockers. So there's a whole bunch of different types of dimmer switches. But you'll see my dimmer switch right here is a slide dimmer. And you'll notice instead of screws, it has wires coming out of it. But it has two black wires, hot, and one green wire, ground, just like our screws on our regular single pole switch. So the black wires will be connected to the black hot wires in your wall, and the bare ground wire or green ground wire will be connected to your green ground wire on your switch. All right. Now, the one thing you do want to make sure of, if you're attaching stranded wire, like the one in my dimmer switch, to a solid wire, you're going to need to use not only the appropriate size wire nut, but you want to make sure when you line those wires up together, the stranded wire is kind of leading the solid wire just by a little bit. This is going to help wrap them together and make a nice tight connection. So you want to screw that wire nut on really, really tight. Make sure your wires twist a little bit and have that nice tight connection. You want to give a good tug on it too to make sure that nothing is going to come out of the wire nut. Now, sometimes when a dimmer switch is installed, you might notice that the light begins to flicker instead of really dim. And a lot of times people will blame that on the switch. They'll think that there's a problem with the switch or that it wasn't wired correctly. The first thing that you're going to want to check is your light bulb, especially with today's newer LED light bulbs. Not all of them are dimmable. It has to say on the box that it is dimmable because if it doesn't, all it's going to do is flicker when you go ahead and add a dimmer switch to it. So that's the first thing that you definitely want to check is to make sure that you have a dimmable light bulb in so that it'll work properly. Now, there are other types of switches, things like motion sensors, fan controls, timers. You're going to want to make sure that you read the instructions that come with those specific switches, but they should all follow the same basic principles we outlined here. Black is hot, green or bare is ground. The white neutral wire usually does not get used when we're wiring switches. Now, there may be one exception to that rule, and those are smart switches. These are switches that can be controlled remotely using either an app like your phone or things like Alexa or Siri or Google Nest. And these can be great additions to your home for both convenience and safety, especially if you're traveling or coming home late. Some smart switches may require the use of that white neutral wire. So just make sure that you're following the directions that are included with that switch, and they will explain exactly how to wire them. Now, that's really the basics of replacing a switch. Now, there's a couple of questions that we always get asked regarding switches, and the most common is about three-way switches. A three-way controls a single circuit from two different locations. So in this situation, think about maybe in your hallway where you have one light fixture in your hall and you could turn it on from one end of the hall or the other end of the hall. So that's one circuit, but it's controlled from two locations. That would be considered a three-way switch. Now, a lot of people want to replace a single pole switch with a three-way switch. The problem with that is a three-way switch has a completely different wiring configuration and often needs to have that 14-3 wire. You're going to need to have an extra wire in there to hook up a three-way switch. All right. So if you're looking to take a single pole switch and replace it with a three-way switch, that's probably a job I would get an electrician involved in because it's going to mean that you're going to have to pull new wire. You may have to cut into your drywall. You might have to worry about, ceiling plates or floor plates within your wall. And it is a little bit more complicated than just swapping out, let's say, a single pole switch for a dimmer switch. So that might be something that you may want to look into calling a professional for. Now that we've talked about switches, let's take a look at outlets, otherwise known as receptacles. Now, most receptacles in your home are going to be these traditional duplex receptacles, meaning you can plug in two separate things into one outlet. Okay. Now, this is the most common. They usually come in a 15 amp and a 20 amp version. Now, these look very, very similar, but you'll notice the 20 amp has that kind of extra little T slot off to the side, right? And that's important. You need to know how big your circuit is because I can put a 15 amp outlet in a 20 amp circuit, but I can't put a 20 amp outlet in a 15 amp circuit. Okay. So if you're unsure of how many amps the circuit is, go back and check your breaker box. That breaker that you've turned off, that will tell you either labeled 15 or 20 and let you know how large that circuit is. Now, wiring an outlet's a little bit different than a switch because when we're talking about outlets, you are going to use that white neutral wire. So if you look closely, you'll see just like in a switch, you have the two brass screws, you have that green ground screw, but then you also have two silver colored screws. Now remember, color means something in electrical. Your brass or gold color screws are always your hot screws. These silver screws will be your neutral. Okay. Now, if you also look at your outlet, you'll notice that with the gold colored screws, if we look at the face, you'll see that that's the same as the short slot. And your silver colored screws are on the same side as the longer slot. So that is the hot slot in your outlet, and that is the neutral slot in your outlet. And of course, on these outlets, this little half moon shape, this is your ground. Now, this is a traditional three-pronged outlet. If you only have two prongs on your outlet, you'll still have the gold, you'll still have the silver, you'll still have the small slot, you'll still have the larger slot, but there is no ground on these. All right. So these are ungrounded outlets. Now, a couple notes about an ungrounded outlet. Just because you see that third hole doesn't necessarily mean your outlet is grounded. So that's really important because an outlet will still work even if there is no ground wire attached to it. Now, the other thing we really need to know about outlets is that outlets are usually run in succession, which means that the electricity is going to come into one set of screws, a hot and a neutral, and then it's going to go out from the other set to another outlet that's downstream or next to this outlet in the circuit. So that's why you may only have one circuit in a bedroom, but four different or five different outlets in the bedroom. It's because they're all run in succession together. Often, when we have rooms where there's water involved, like a kitchen, a bathroom, a utility room, you may see an outlet that has the buttons on it, right? This is what's known as a GFCI or a ground fault circuit interrupter, right? This is a special kind of outlet that kind of acts like a mini circuit breaker that if for some reason the electricity finds an easier route because that's the thing with electricity. It's always going to find the path of least resistance. If it finds an easier route, it's going to go ahead and trip and shut off that breaker before anybody can get shocked or worse, before there can be a spark that may potentially cause a fire. Now, like I said earlier, with the regular standard outlets, right? You have a set of wires going in and a set of wires going out. And normally, it doesn't matter which set go on the top and which set go on the bottom. But in a GFCI, it's very different. In a GFCI, we kind of talked earlier about that home run, that wire that's coming directly from the breaker box to the first box in the outlet or the first outlet in the circuit. That is going to be what is known as the line, right? And then anything that goes from that outlet to additional outlets, that's going to be known as the load. And you do need to know the difference between line and load in a GFCI outlet. And you'll see right on the back of the outlet, it is clearly labeled which set of wires need to go into the line and which set of wires need to go into the load. Let's go ahead and demonstrate how to replace an outlet. For this example, we're going to go ahead and replace a standard duplex receptacle with an outlet that also has integrated USB ports. Now, this will be the same process if it's a USB or USB-C ports. Again, first, always make sure you're turning off the power at the breaker box. Go ahead and remove that cover from the existing outlet and test to ensure that your power is actually off. So you're going to want to unscrew the existing outlet from the box and pull it out of the box so you can access the wires. If you want to take a picture of the current wiring, this would be the time. Remove those old wires from the outlet. Now, you're going to notice on this new outlet, there's only one set of screws, one brass and one silver. Now, if this is the last outlet in the circuit and you only have one set of wires, you can use the hook method like you saw in switches earlier. But if this outlet is kind of in the middle of the circuit, you're going to have two sets of wire. Now, each screw can take up to two wires, but not utilizing that hook method. You're going to need to straighten the wire or cut off the hook and strip back the wire. You're going to want to use that wire strip guide on the back of the outlet to ensure that you do not overstrip or understrip the wire. Loosen up that screw and slide the wires on each side of the screw underneath the small plate. And when you tighten the screw down, the plate that holds the wire in place will also tighten down and keep everything locked in. Now remember, that black wire goes under the gold color screw and the white wire goes underneath the silver colored screw. As long as you have that wire stripping guide, there should be no bare wire showing from the connections. And now you can attach the bare wire to the green ground screw and tuck all of the wires back into the box. You're going to want to screw the new outlet into the box and attach the cover. Go ahead and turn the power back on and test your outlet. And that's really all there is to installing a new outlet or replacing an outlet. The most common question we get regarding outlets is, how do I determine that line from the load when wiring a GFCI outlet? And this is really a simple process, but it needs extra safety precautions. With the power off at the breaker, remove the outlet you would like where you would like the GFCI to go. You want to pull those wires as far out of the box as you can and separate them so that there is no way that they're going to touch each other. You want to move away from the wires and turn back on the breaker. Now, you can have somebody else do this, but if you're working alone, make sure that there's no people or children or pets anywhere near these wires when you turn that power back on. It is safer to do this with two people. With the wires separated and the power on, you're going to use that voltage tester to see which pair of wires is hot. Now, this is going to be your line set of wires. Only one pair is going to be hot. This is going to be your line. Note which pair that is. Go ahead, turn back off the breaker, all right? Or have someone turn off that breaker for you and double check that there's no longer power running through it. You can go ahead and label the line wires once you know there's no more power going through it. You can wire up your GFCI outlet just like any other outlet, making sure that you put those line and load wires in the correct place. So we went over a lot of great information today. Of course, we started talking about safety because it's the most important part of any project, but especially your electrical projects. We discussed some of those basic tools that you're going to need. Not really very complex, but some specialty tools for sure. Now, these are all the tools that you should really need to change out your switches and your outlets. We talked about some different types of switches out there, as well as how to wire up that basic single pole switch. And of course, we looked at some outlets, including those GFCIs and specialty outlets with USB or USB C charging ports, and that process on how to go ahead and replace those. The only thing left to do is thank you. On behalf of myself and the whole Workshops Live team, I want to thank you for joining me today. I hope that now you have the confidence to take on these simple repairs and updates on your home. And always thank you for letting me help you doers get more done.